Hello, welcome to this video where I'm going to do a kind of speed solve slash walkthrough of the Road to Las Vegas vending machine case that came out yesterday. This was actually the first time I had attempted to do this live as part of the qualifications for the MEWC. So a couple of caveats. I will try and not use any lambdas if I can. I should also say I've now been through this case a couple of times since the event, working out where I went wrong. I'll try and give some commentary as I go along in terms of what I did on the day and what obviously I worked out afterwards. But this hopefully shows that yes, as it is a challenging case, but in theory could be done in half an hour, although I'm not sure if anyone actually did, and if they did, hats off to them, because there's a couple of bits, particularly on level 6 and very much level 7, that took a lot of time for me to work out, and not sure if I would have ever been able to recreate that under timed conditions. So yeah, that's enough introduction for now. Let's get the starter pistol fired and let's get going. So we shall start the game. Okay, so let's go to, even before we do level 1, we need to do some data prep. So we've got our vending machine here, so I'm going to start by doing a 2col of this grid, but I'm going to use the scan by column, because when I then combine that with wrap rows and a wrap count of 3, we get some quite nice tidy data. And I'm actually just going to copy and paste that as values only, because it's not going to change. I'm also, and this is again something you wouldn't have known on the day, but having done the case, I realise now will make life easier, is to multiply these prices by 100, so I get the cent values rather than the dollar values. And let's just replace that there. And then the last thing I'm going to do is I'm going to tidy this table. I'm going to call this slot. I'm going to change product to item, because we don't like product, because product gets used in Excel in certain it is a formula in itself, and so when you do anything like that it can get confused. I'm going to change this table name to T so we can quickly reference it, and then I'm going to look up the slots in here and return the look up the slot and return the item. And again, I'm now going to call this symbols, slots, prices, and I'm going to say items rather than products. And I'm going to select all of this, Control Shift F3 to name this as my data. And so that's done most of the work we'll need to do in terms of data tidying, because this first one we just need to look up the slots reference, which is here, look it up in the slots and return the items. And then we've got our item names, and that's level 1. And then let's go to level 2, which now we've done our prep, which is going to be as easy as level 1, because we just look up the products in the items and return the symbols. And now we've got our symbols as well, which, if we go to find our answers, is level 2. Okay, level 3. Level 3 is our first one where we've started going multiple inputs, so straight away I'm going to put this into a data table. I'm going to turn this into a col, because I prefer to work in columns. It'd help if I put the hash symbol, and then we want to look up these products in the items and return the prices, and then we want to sum those, which I probably could have all done in the same cell, but there we go. And we get 1075, and that returns our other values, and that's level 3 done. Okay, let's go to level 4. This time it was level where we've got slots that have been ordered, and we have to work out who's the first to reach 10, i.e. to run out. So firstly, let's text split cell B1 on the row delimiter of a comma. And because this number change, this is one of the things that threw me on the day, and since I've kind of come up with this solution where we need something that's like dynamic, so I'm going to use sequence to count how many there are there. And then what I'm going to do is here, what we're ultimately saying is we want to count ifs this, not this whole range, but so we're going to take from this range the number of our current row, and then what we're actually doing is counting ifs that contains the current item. So again, we're going to index from our spilled array the current row as well. And that's how I do it run by one. But now I'm going to turn that into a lambda where my input is the row number from my sequence, and I'm going to replace my cell reference with the variable, return an error. But when we then combine this with map, we map over those sequences, or that sequence, we now get all of our countifs, and we're looking for the first 10. So we're going to x lookup 10 in this array, returning this array, and then let's just wrap this in another x lookup. So we've got a slot there, so let's look up slots and return items, and we get catfish crackers, which when we press equals, and we now have something that's fully dynamic no matter how many different entries they decided to put in there. Okay, level 5. Level 5 was where we had to text string, and we had various versions of enter and delete, and I completely went down the wrong way with this when I was trying this for real. I was trying to find when the first enter was and when the first delete was, and then work out which happened first, and then use text before and text after, and it was row by row spilling out, and it was very rough. But if we use regex extract, we actually find out what we're really trying to do is look for the word delete, but also whatever is in front of the delete. So by putting a wildcard in front of delete, we're actually extracting the delete and the number before it, which we don't want to have. So actually if we change that to regex replace and simply replace it with nothing, we now have the string without any deletes, and we've removed our deleted characters. So now we can just text split this on the word enter, but we want it per row. And now we have our items that we end up with a blank one at the bottom. So I'm going to drop the last row, and then I'm going to x lookup these items in the slots and return the prices, and I'm going to sum that range. And now we've got our values, and that's level 5. Okay, then we return, let's go on to level 6. So level 6, we've got lots of people in different orders, and we have to work out whether they get their first preference, their second preference, or third preference. So we're going to go to this table. I'm going to rename the columns so they are quicker and easier to change. I'm actually not going to make it into a table. I'm just going to use Control-Shift F3 to name the ranges based on what's on the top, because we don't have to do anything else to this. And then this, I had to build a bit of a let for this. So we start by taking this and spilling it out into columns, but we don't know how many of these we're going to have. So what we want to say is we want to create a let, and we want to take a player, and we'll refer to this as our first player, and then what we need to find is what their preferences are. So I'm going to say preference 1 is x lookup player in player and return pref1. And what I'm going to do is, firstly, that works, we get diet roller cola, but I'm now going to copy this preference little bit of formula twice and just update it. So we've got preference 2 is looking up preference 2, preference 3 is looking up preference 3, and now we also want to work out the count. So how many times have each of these appeared? So I'm going to call this count 1 is going to be count ifs, and my range is going to start above our cells, and I'm going to lock the third row, and we want to know whether that equals the first preference. And again, I can do the same thing where I've written that once. I can put this here twice and just update the numbers. So count 2 will be counting preference 2, count 3 will be counting preference 3, and now we're going to finish with a little if-then logic. So if the count of preference 1 is less than 10, it hasn't appeared 10 times, then we can take preference 1. If not, we'll look at the count of preference 2, and if that is less than 10, then we can take preference 2, and if that's not the case, then we look at count 3. If that's less than 10, then we can take preference 3, and if none of those are true, then they must get no item. And we'll accept the correction. And what I'm going to do is I'm going to drag that down. And for now, some of you will see the problem already because what happens when we have a different number of these. But for now, let's not worry about that. So X look up the product in the items, returning the prices. And if we don't find anything, return a 0. That's great. And if I just say sum of everything in this column, it's going to work for the example, but pretty sure when we put this in, it might look like it's working for us, but let's say we pick another one. Okay, we need to drag our formula down. So let's just double click that. But now we're getting some errors. So what's going on here? This is all part of the debugging. We realize that if the number of people is not the same as this, then this returns an error. And if that's an error, then the lookup becomes an error as well. So what we need to do is wrap this in an if error, which is not the neatest way of doing it, but hey ho, that's what we'll do. And I'll copy that down, and that'll remove the errors. But again, we still don't know for certain if they are all the right length. So what I'm going to do is I'm going to copy from the case all of the actual inputs. And this is the only place where I'm going to use my lambdas, because I'm just going to do quickly count occurrences of commas in this cell. And there's 209 commas, which means there's 210 players. I'm going to put this down here, and then what I want to do is find the max. So the max is 248, so there were 248 cases as a maximum. So if I do a sequence of that, and then down here, if I make sure that goes all the way down to 248, I shouldn't get any errors even on the longest case. And now I'm going to take my answers and I'm going to go to the place, and there we go, we're good. Alright, so just over 10 minutes gone, so we've got all the rest of the time to do level 7, which was obviously, as you'd expect, the most difficult. So level 7, I'm going to set up a table. Firstly, we need to wrangle this data so it looks tidier, so we're going to use text split. We're going to take advantage of the fact that we can split by row and by column, so we're going to split the row on the commas and the column on the semicolons, and we have data that looks quite good. We want to get rid of those errors, so let's pad with 0, and this tells us our slots, and these are the coins given, and this could change in size. So if I go to another example, it not only does it get deeper but also goes wider, so we need to take account of that. So what I'm going to do, I'm going to copy this formula over here, and I'm going to drop the first column because I don't need the slots over here, and then this time I'm going to do the same thing. I'm just going to take the first column. So now I've got my coins given and I've got my slots, which we'll come back to. So let's deal with the coins given. We want to work out how much has been given and how many coins we were. So I'm going to say we've got 100, 50, 10 and 5 are our coins. I would start by saying, right, I want to see how many of those equals that. It's going to spill, but if I put this into a sum, I then get a number. Oh no, I don't, because these are not actually numbers yet. So I'm going to multiply. Now normally I multiply by 1, but because we want to deal with actual values, I'm going to change it by 100. So now that gives me values, good, but I need this to be dynamic so that if this changes, this changes. So what I'm going to do is I'm going to turn this into a lambda. So I'm going to say lambda on a row, and that is my row. And then what I'm going to do is I'm then going to say by row over this, and now we get a dynamic version. And if I lock that in place, and I also lock, actually I don't need to lock that row, but just in case, and I'll get my total. So in this one we get 200s and 150 and nothing else. Okay, that's great. Now we want to work out how much they actually paid. So this is a nice easy by row, because we just go over that and just sum it. So we've got our amount paid, but what was the cost? So we need to X look up the slot in the slots and return the prices. And so we need to know what the change given is. So the change is going to be how much they paid minus how much it cost. And here comes the trickiest bit of the whole case, certainly for my things, is how do we turn this number back into the number of coins. Okay, let me make a little bit of extra space. It's basically based on the idea that if we have different denominations of coin, and let's say we need to find how much change there is in 275, what we would do is we'd say, well, how many hundreds go into 275? So we'd say we'd round down 275 divided by 100, and that gives us 2. So 200s in 275. Then we need to know how much is left over, so we take the 275 and we mod it by that divisor, and that's 75 left over. And if we repeat that process, we then find we've got 150, 25 left over, 2 10s with 5 left over, 1 5. So that's the basic idea here, but let's build this into a lambda. So we'll start with a let. So we're going to say we've got an amount, which for now I'm going to say is 275. And first I want to find out how many hundreds there are. So I'm going to round down my amount divided by 100 to 0. And that's going to give me a remainder of 100. Sorry, it's not going to give me a remainder, but I want to know the remainder, which is the mod of my amount and 100. And for now, let's just call that hundreds to show we should get 2. Brilliant, we do. So let's go into this, and now let's copy this and do this for each level. It's going to need to do it 3.5 times, so let's do 50s. So our 50s are rounding down no longer the amount, but the amount that was left over previously, not dividing it by 100, but divided by 50. And our remainder for 50 will be the mod of the amount from the previous round, mod 50. In fact, I'll copy this one because it's slightly more close to what I want. Then the 10s is going to be a rounding down of 50 to 10, and the remainder for 10 will be mod of 50 by 10. And then finally we need our 5s, but we don't need any more than that because there's nothing else. So our 5s is the rounding down of the 10 remainder by 5. And just as an example, yep, we're still getting numbers. So what we're going to do is we're going to H stack those together. So we've got the hundreds, 50s, 10s and 5s. Close off the bracket. Oh, what have I done wrong? Round down 50s, 50 or 10. Oh, I've spelt hundreds wrong. There we go. And there we have it. Right, let's make a little bit more space because we kind of want to end up with this up here. I can get rid of this for now because that was just, oh no, I can't because that's referencing that. So let's take it to the change and then we can get rid of that. So now we have to work out how can we get this to be dynamic. So what I'm going to do for now is change this into a lambda where amount is my input and I no longer need the input inside the let. And let me just point at that to show it's still working. But now I need to do something stacking. So this is where I'm going to put it inside another let, and I'm going to call this f for function. And I'm now going to use reduce over an empty starting point. I'm going to go over this array, and I'm going to use a lambda with my accumulator and my current value. And what I want to do is I want to v stack the accumulator with my function being worked out on the current value. And when I do that, it's going to stack each resulting value as a new row. That random empty row is because I started off with an empty row, so I need to drop that. So I'm going to go drop 1, and now that's my coins out. So this is coin, that's going to get an extra row. So this is coins out. And we've got coins in over here, so we need to work out the difference between them. So make a little bit more space. So we want to start by, let's stack together these dynamic arrays to make this a dynamic array. So those are the coins in. So we want to minus the coins out. So that's the change in coins. And then we started off with 50, 100, and then 150 and 150. So we got 50, 100, 150, 150. And so if we sum this range and this dynamic range, we get 459, which is our answers. And if we go to the answers, there we go. So yeah, that was about 8 minutes, and that's knowing in advance what to do. So I mean, that's crazy quick. If I'm presuming someone else who's done that, if they've done it in the time, they've taken a different route because that was quite involved. So let's get on to the bonus questions. Somehow it's dropped to the bottom. So if you take the codes of all the beverages and remove the letter, what is the sum of the numbers? So we go to the vending machine. Our beverages, thankfully, are all down the bottom, so it's these ones here. So what we can do is, because we know they're all 3 digits, we can just say the right of those 2, but that's text, so we multiply by 1, and then I'm just going to sum that, and that gives me 826, which I'm just going to post straight into here rather than the worksheets, but we'll come back and do that. But let's do both just to be nice and neat. 826. How many capitalized letters across all the product names? So if let's concatenate all the product names, and then let's use a bit of regex. So we regex extract from that any capital letter, so the set of capital letters A to Z, and we want every match, which will spill them out, and if we just count those, we get 100. That's a nice easy number to remember, 100. And we'll go back here. How many times has the delete button been pressed across all level 5 orders? So let's go to, actually we can do that in here. So level 5, how many times? So I'm going to concatenate all of those again, and I'm going to use my lambda, which is, well, I say my lambda, I got it from someone else. The occurrences of delete within that is 29. So we'll go back here, 29, and back to the top, 29. Okay, what is the total value of the products left in the vending machine after all level 6 games, excluding the example? Provide your answer in sense. This is level 6. So this is all the values of what has been ordered. So if we know how much was in there in the beginning, we can work out the difference. So if we take all the prices and multiply them by 10, because there are 10 products of each at the start, and then sum that, that's 97,000. So if we say 97,000 minus all of these values, and then just sum those up, so that's how much is left. So 917525, let's copy that in case I mistype it. 917525. 975. So how many coins did the vending machine return across all level 7 games? So we're going to take a copy of the level 7, we'll just quickly rename it bonus 5. Just for neatness sake. So this time the number we're interested in, not 459, we're interested in how many coins were returned, which is this. So if I just say sum of that, gives me 4 on this round. So if I change my data table to look at that, and then sum these numbers, we get 1971 down here. So we'll go 1971, go to the case, 1971, it thinks about it, and then boom, job done. Okay, we'll stop solving, and what was that? 22 minutes and 20 seconds. So that is obviously, like I said, I've been through it 2, maybe 3 times now, and taking my time and just improving the methods each time. There's a kind of description. So in the live competition, I was able to do level 1, 2, 3, and 4. Fairly straightforward, although the approach on level 4 was it took me a while to get that right, because I got caught out by the fact that the number of inputs changed, which is not something that happens that often in the cases I've seen. Not that I've done that many, but typically the ones I've seen, it's the same number of inputs, you just build something. So having to work a bit more dynamically. Level 5, as I said, I managed it, but it was very tricky, where, like I said, I was saying search for enter and search for delete. Tell me when you find them, whichever is earlier. Then if it's enter, then chop off what's in front of it and look it up. If it's delete, then chop off the one before and then re-go. But my model didn't account for cases where delete was the first thing to appear. So I think I got this one and this one wrong because delete is the first, there's not an enter, so I didn't take that into account. Level 6 I didn't even get started on. When I looked at it, I was like, no, I'm going to go back and try the bonuses. And then I think on level 6 I tried to kind of almost do it by hand for the because I had so little time left. So I think I might have got one of those right just almost by pure luck. But yeah, so that shows that in theory the case was solvable in half an hour. Like I said, I don't think I'd have to have a look at the results to see if anyone actually did. But yeah, very good case. What I liked about it was one thing I liked about it and one thing I didn't. One thing I liked is that the levels were independent. So a lot of cases I've seen, if you don't do level 4, then you can't do level 5 and so on. They develop the ideas, and that's quite frustrating because if you get stuck, you just have to keep working and keep working. Whereas this, the levels were independent. So if you looked at a level, didn't like it, or you got stuck, you could go on to the next level and just start afresh. So I really like that. The thing I didn't like, which I've mentioned a couple of times, is the fact that the number of inputs for each game in some of the higher level games were different, which meant you really had to work on creating dynamic solutions that could account for the fact that the number of inputs was different. So yeah, hope you found that helpful. If you have any thoughts, comments, just feel free to let them know. As I said, still fairly new to this, so I'm sure any of you who are watching who have done this more than me will be thinking, oh, you could have saved a bunch of time by doing that, and so on and so forth. But there we go, it's all part of the learning process. So thanks very much for watching, and see you next time.